partners Madeline Bennett and Palin Mercer will discuss the influence of GMOs on the health of the general population. Genetically modified organisms, or GMO crops, benefit humans by increasing food security, reducing food waste, and lowering consumer costs. From the first GMO crop in 1994, which is shown in this picture with Dan Grierson, a scientist at Calgary, holding the Flavor Saver tomato, to the massive commercialization in the late 90s and the transparency laws of 2022. Approximately 1.93 billion people throughout US, China, Brazil, and India regularly consume GMO foods directly or indirectly through animal feed. This leads us to ask, to what extent do GMOs influence the overall health of the general population? To answer this question, the economic lens must be taken into consideration. GMO crops contribute to increased farmer income by improving farm productivity and crop yields. Brooks, a director of PG Economics, reports that farmers worldwide who adopted GMO crops saw an increase in their incomes by over $261.3 billion between 1996 and 2020, with 72% of these gains resulting in increased yields. This graph is by Brooks, and it shows the average yield gains of BT cotton by country from 1996 to 2020. This graph shows that farmers' income increased in all countries, with Argentina rising by 30% and Brazil rising by 2%, demonstrating overall growth regardless of size gain. Furthermore, research by Brooks and Barefoot, agricultural economicists at PG Economics, indicates that GM technology increased global output by 363.8 million tons for soybeans and 655.9 million tons for maize, reinforcing the idea that GM crops reliably improve global farm profits by significantly increasing harvest volumes and smoothing production.
The environmental lens also must be taken into consideration. According to Brooks, agricultural economist and director of PG Economics, GMOs significantly reduce greenhouse and carbon gases, which in 2020 was equal to saving 23,631 kilograms of CO2, which is equivalent to taking 15.6 million cars off the road for a year. Over a 24-year period, the widespread use of GM insect-resistant and herbicide leads to important cuts on farm fuel use, improving changes on carbon emissions, shown on this graph here by the Department of Sustainability. Since 2018, there's been a 16% decrease in CO2, with a 63% reduction target by 2030 and a zero target by 2050.
From a scientific perspective, genetically modified crops improve public health by increasing nutrient content and reducing exposure to harmful toxins. Swami of the International Rice Research Institute found that GR2 golden rice maintained normal protein, fiber, and mineral levels, showing that biofixation does not reduce overall nutritional quality and can be a sustainable use of vitamin A. Gomez et al. Reports fungal contamination affects about 25% of global grain supplies and leads to dangerous mycotoxin production. Together, these studies show that genetically modified crops are scientifically supported tools for improving nutrition and food safety. As you can see from this photo from ResearchGate, this side is the side with non-GMOs and this is the side with GMOs. You can see the difference in the vegetable in the quality of the color. After recognizing the complexity of this situation, we developed two potential solutions. One possible solution is that the national government and public institutes can extend the solution by distributing golden rice seeds royalty-free through public sector programs. As you can see from this photo from Feedstuffs Today, this farmer is manually taking golden rice seeds and distributing them into a field to ensure that the most vulnerable families get an everyday source of vitamin A. During a 2009 controlled study conducted by Tang et al. Demonstrated that beta-carotene golden rice was efficiency converted healthy adults using an isotope tracking method, confirming that the nutrient is both present and functionally effective in the human body. Some implications of this include a long-term nutrition source, and it ensures more families have access to a source of vitamin A. This solution does come with some limitations which are emphasized by Gomez et al. These implications include public distrust of GMOs, distribution problems, and not all nutritional problems are solved. As you can see from this photo from Feedstuffs, this side is the side with GMOs and the side with non-GMOs. You can see the difference in the color of the two and the crops and just how the nutritional quality works. Considering the lengthy list of limitations, we developed a stronger solution.
Our stronger solution is promoting no-till farming to enhance soil health and reduce carbon emissions by using fewer tractor passes. According to the U.S. Department of Agriculture, promoting no-till farming enriches soil and increases soil water. This photo by the U.S. Department of Agriculture shows a tractor promoting the no-till farming. And then Bernard et al. Claims that USDA's Common Farm Tools can reduce farm carbon emissions by 69%. Our stronger solution has some limitations. High herbicide dependency creates in chemical use. Shu et al. Agriculture economists for the National Library of Medicine argues that over the last 20 years, intensive glyphosate use-resistant cropping has caused over 34 weed species. This picture here by the Genetic Library Literacy Project shows a tractor which is considered heavy equipment. According to Minta, heavy equipment is a costly resource and can result in a financial burden. However, our stronger solution has some implications. For future impacts, improved soil health. According to the World Economic Forum, soil provides 95% of our food and climate, and reduced carbon is also an implication as well.
Overall, GM crops have improved nutrition and strengthened food security, and they are widely used around the world. However, without expanding efforts such as distributing golden rice through public programs and promoting no-till farming practices, problems like vitamin A deficiencies and environmental damage will continue in the future. These are the sources we used to research our argument. Thank you for your time.
Thank you very much. I'm going to start over here with you, Maddie. So, Maddie, how did the group decide to include Anna's perspective, lens, and conclusions into the overall presentation?
Anna's economic perspective was focused on reducing farmer income and improving crop yields. We decided to include Anna's perspective because it gave us a bigger picture on all of our arguments.
And Palin? Palin, could you give me one specific way that your thinking changed as a result of learning about Maddie's findings?
After learning about Madeline's findings, it showed me that GMOs not only help with food production, but also benefit the environment. Their findings showed me that GM crops reduce greenhouse gas emission and increase carbon shortage, which helped me see that GMOs are more environmentally friendly than I originally thought they were.
Very good. And Anna, reflecting on your colleagues' work, which one had the greatest impact on your overall understanding of the problem your group identified?
My partner, Palin Mercer, helped me understand the benefits of GMO crops by her explanation as to how golden rice affects human health. She explained to me how golden rice can combat vitamin A deficiencies, which help improve immune systems, can help prevent childhood blindness, and reduce mortality rates caused by severe vitamin A deficiencies in developing countries.